All right, dear students, welcome to your number patterns series. We are going to do number patterns. We're going to start with linear patterns, then we're going to do quadratic pattern. So these number patterns are actually quite an easy chapter. So let's go ahead and start right here. So looking at what we have here, I put a few number patterns here for us to view. Look at this one here at the beginning. It's 2, 4, 8. You know, there are certain numbers that if they are arranged like that, if they are put like that, you can actually guess the next one. So if I carry on and say 2, and I go to 4, and I go to 8, I think you can quickly see what I'm doing. As multiplying by 2 the number just before that. So you will be able to go and say 16 maybe, and then you should be able to go and say 32. So it's very easy to see the pattern we are following. There's a particular rule to it. Okay, so on this second one, let's see if you'll be able to pick up what's happening. So there is 1, 3, 5. What do you think will be my next one? Well, if you figure it out, I'm sure you say 7, and then you should have 9 carrying on. In this situation, you notice that I am actually adding 2 all the time to go to the next one. So this one will be better. So we can see that we are adding a certain value all the time. Well, that's one form of a pattern that we're going to talk about. Well, let me see how many of you will see this third one. It's an interesting one, really. 1, again 1, then 2, 3, 5. Well, if you do not know this one, it's quite difficult to pick up. In fact, it's the Fibonacci number pattern. So you notice that you have to add the previous 2 to get to the third one. Okay? So if you want to get to 3, you have to add 2 and 1. You add this previous 2 to get to this one. And then now you have to add this one and that. So you will know that your next term should be 8. And if ever you want to go to the next one, you have to add these 2, and I'm sure you'll go to 13. So this one is a different type of number pattern. Well, we are not going to talk about those ones much. So today, for this particular lesson, I want us to talk about the linear one, like this one at number 2. This one right here, the one where you keep adding a certain value to carry on. So I'm just going to randomly put other terms. Let's say I have 2, and I go to 5, and I go to 8. If I say this is a linear, or there is a constant value that I'm adding, from 2 to 5, you can see that I added 3. And from 5 to 8, I added 3. So you can tell me the next term now. I think you are figuring that it should be, if we add 3, it should then be 11. So as you are noticing, the one that we are going to call linear, these are the linear relationships that we're talking about here, or linear number pattern. So you can see that there is this constant difference that I'm talking about here. Between 2 and 5, you can see that it's 3, and it's 3 everywhere. So what we are going to do in this number pattern, we are going to call our first term A. We are going to denote it with the letter A, and then the difference, this one, we are going to call it D. So these ones, this one will represent the first term, as we do in every sequence that we're going to have, or in every pattern, and then D is going to represent that which is a constant difference. Remember, it is only linear if the first difference happens to be constant. So if it is not constant, it means it's not a linear pattern. So I think you're grasping this. So your A is your first one, and D, we're going to use the letter E to show the common difference. Okay, let's call this one, let's just do that. Why don't I put another one? Let me think of something else. What if I say -1, and I say 4, and I say 9. Do you think you can give me the next one, or figure out what I'm doing? Well, I think you notice I am adding 5 all the time, so I think you're ready with your 14 now. So as you can see in this one, if you check this one, you will see that there's a difference of 5, even here, difference of 5, and a difference of 5. How am I getting the difference which we are calling D? I'm either saying T2 minus T1, or I can say T3 minus T2, because T, the first term, we're going to call it T1. The second term, we're going to call it T2, like that. So T is going to represent the terms. So I can calculate D like this, or I can as well just have it in this form. Okay? I can as well just think of a formula, a common difference, Stn minus the previous term, which will be Tn minus 1. It's really not too difficult to figure this out. So here is what I want you to see. We're going to just use this number pattern here. This is the formula that we're going to use. But maybe you are wondering where it is coming from. So taking this number pattern again, remember we had this one, it says 2, 5, 8, 11, we already have it. Well, remember here, our A, this one was our A, right? Our A was equal to 2, and our common difference, we have it up there, is equal to 3. So I want to rewrite this again. Look at it. 2 can simply be written as A. If I write this in terms of A and B. To get to 5, I simply have to add 3 to 2. So it means I say A plus B in this situation. Well, to get to the next term, I needed to add another B to the second term. So it means the third term, if I keep adding the common difference, which is D, if I add the common difference to this term, I will have A plus 2B. And now to get to the next term, I have to add B to this term. And of course the next term will be A plus 3B. Well, if you are noticing, this term here is in place of T1, this is in place of T2, this in place of T3, and this in place of T4. You are noticing that the number of D's you've got here is 1 less than the number of terms. If we are dealing with 2 D's, it means we are on T3. If it is 3 D, it means it's T4. So what it means is that if I am dealing with Tn, I'll also say A plus, but I have to reduce my number of D's by 1. That is why you will have N minus 1 D. So this is the formula we are going to use to get to what we call the general term. Some of you may wonder, why general term? Why do I need that formula? Please notice, if I ask you for the next 2 terms for this one, you will gladly do it. In fact, you just say 14 there, and you say 17, it won't hurt you to carry on. But if I say, give me the term in the 100th position, in other words, I want T100 here. So you have to carry on until the 100 terms. Believe it, you will feel it's getting tedious to keep adding 3 and adding 3 until you get to 100. So that's where we need a formula, such as this one, the general formula of the nth term. Then if you have this formula right here, you can easily then calculate T100. What do I need? For example, for this particular question we are dealing with, just the same one here, I'm going to say your A, remember your A was equal to 2, and then you put N minus 1 here, you put your common difference, remember it was 3. So it will work out this way. Tn is now going to be 2. Let's simplify that one slowly. It will be 3, and you know 3 has to multiply into this, into the bracket, those 2 terms. So it's 3n minus 3. As you can see, I can simplify this, and I will have 3n minus 1. So if I have this nth term, or the general term, I can easily calculate any term at all that they're asking me in the sequence over here. So like I was saying, if I want T100, I can go ahead and calculate it by substituting into this formula. So it will be 3 by 100 minus 1. So I'll be able to tell immediately what term will be in what position. So as you can see, I'll get my 299 with no problems at all. Alright? Right, so principle, this is the formula we're going to use. A plus n minus 1b. We've got it here in our notes. I hope you saw it at the beginning. We have it over here. I wrote it again here. So you should be able to understand what we want to do here. Let's get to the questions. Let's have a few of the examples that you can also enjoy looking at and also answer with me. So we have the following sequence. And actually, what you eventually want to do is to get the 12th term. Well, you can carry on and get more terms, you can go ahead and say, after 19, you may check the differences here. First of all, establish if it is a linear pattern or not. So if the first difference is not constant, it won't be a linear pattern. If it is constant, then it's a linear pattern. So to get the common difference, you have to say 12 minus 5. And that should give you 7. And then when you say 19 minus 12 and you get another 7, now you are content that this thing right here is a linear pattern with the first term of 5 and a common difference of 7. So once you have that information, now you are free to calculate what we call the general term. So you can go ahead and use this formula n minus 1b. Excuse me. So to get it in this situation, you will go and say your A is 5, and you put n minus 1 right there, and your common difference are 7. So let's see if we can simplify this. So it's 5 plus 7n minus 7. So I think everyone can see how that we have to find it. Okay. You are noticing how Tn in this situation is simply going to be 5n, or rather 7n. What is 5 minus 7? I think 5 minus 2. So with this here with you, this is your Tn formula. So if you have your Tn formula, you can easily calculate any term that you want. Remember, Tn represents the term itself. And this 12 is representing n. So n here is the position. This n is the position. Tn is representing the term itself, here itself. So let's go ahead and find T12. I'm going to go and say 7 by 12 minus 2. You can use your calculator, or you can just use your calculator. So you can see you should be able to get to 4 minus 2, that should be 82, right? That would be a T12. So that's how we solve these problems right here. It's very simple. There is nothing much we can do to a linear pattern to make it more interesting. It's unfortunately just this. So let's go ahead and solve the second example. I hope you will be able to follow here as well. We'll let you create the next steps. Right. Looking at what we've got here, I am noticing that I have to look at that. It's 3, and there is 5, there is 7, and there is 9. The first thing I want to see is if there is a common difference. Is it constant? Is the first difference? So we say 5 minus 3, you get 2. 7 minus 5, you get 2. 9 minus 7, you get 2. Good. It's constant. So this thing, at this point, you can tell that it is a linear number pattern. We can call them the arithmetic number patterns as well. So your A here is equal to 3, and your common difference is equal to 2. Those are the things you really need before we start answering. So the first question here is asking you to determine the nth term. It's the same as saying the Tn, or the general term, and also find the 180th term. So let's go ahead and find the general term first, or the nth term. We go into the formula, make necessary substitutions, and go ahead and get all the marks. So here your A is 3. And n minus 1, then your common difference happens to be 2. So to simplify this, I'm going to get the general term as 3 plus 2n minus 2. I think you are fine if I write it as 2n plus 1. Okay, so that's our general term. Firstly, that's what we will ask right here. So now we would like to calculate the th term. So all I want now is to calculate t 180. So all I need to do is to substitute in place of n, I put 100 and 80, and then say plus 1. So this should be simple to see. We need to put an equal sign this side. Sorry about that. So we're going to get, so we have 360 and then 1, so we should get 361 here. Okay, so that is very simple to see. Please check it out. It's something that is easy to do. Well, let's go. This one, let's answer this one together again. We have negative 2, we have 3, we have 8, and we have 13. If I check if the first difference is constant, let's check if that is the case. If I go say 3 minus 9 is 2, I am getting 5. 8 minus 3, I'm getting 5. 13 minus 8, I'm getting 5, and therefore I am convinced that this thing here is a linear number pattern, or is an arithmetic sequence. So what we're going to do now is to appreciate how our A is related to 2 and our B is 5. And then from here, we just get the general term. So you want to find the nth term. If it's the nth term you want, the nth term you shall find. So here it is. You substitute your s as your negative 2, and then you have n minus 1. The common difference is 5. So when you simplify that one, it should be 5n of 11. I will just show you this thing. 5n minus 5. And then of course, if you get the general term, it will now be 5n minus 7. Right. So now after you get to 5n minus 7, now 5n minus 7, we want to figure out which term is equal to 753. So for B, you want to find that 753 is in place of the term, is the term itself. So if it is the term, you substitute it in place of Tn. If it was the position, you are going to substitute it in place of n. So you first of all have to check the numbers you are given, whether they are positions or they are terms. 753 is actually a term itself. So it goes in place of 3, in place of Tn, right? And then you go and put that in. So as you can see, your 5n is now going to be, is that supposed to be 760, and then if you notice, when I divide by 5, all of that I should get 152. So what I'm getting from all this is that T152 happens to be equal to 753. So understand it properly, please. What we have here is 100. The position of 753 happens to be 152. So it's on the on this position here, 152nd position, and then this one here is the term itself, the 753. Okay? It should be easy to notice. Okay, before I go, noticing that here on A, you are seeing that we also had to find the 259th term. So if you would like to get T259, please notice when they give it to you like that, it means it's the position of the term. 259 here happens to be equal to n, not Tn. So you would like to find the term itself that is at that position. So you go and substitute into this formula. Again, you say 5 by 259, and then don't forget to subtract 7. Okay, let's just use the calculator. getting 1,288. So that's what you're getting right there. And it's linear patterns, easy things to do really. Okay, let's go ahead and give you a sum to do. Practice this one on your own, please. Answer this one. Quickly pause the video, answer this one. Good. If you have answered this one, well done. So let's go ahead and do it together now. Let's see what it is that you did and what you did not do properly. So the first thing was to write down the value of the next two terms. So you first of all have to establish what type of sequence you've got. So 2 to 7, that would be 5, and even here it's 5. I have a feeling we did something of this sort. Maybe just a few minutes ago. Well, this is still 5. It was just slightly different. Okay, so if we have that difference of 5, you have to write down the value of the next two terms. To get to the next term, you just have to add 5 to that 17. And it will not disappoint you. You will get 22 right. And if you add 7 to that, and rather 5, you should get to 27. So you wanted the next two terms, and the next two terms that you want should be 22 and 27. It's very simple to get marks. Those 2 marks were the easiest, so you just get them like that, and then you get your 2. Okay, so easy. Now you want to determine the nth term for that. So to get the nth term, I'm going to have to lower this down a bit. So if you want the nth term for the expression, I think this is what you did. A plus A minus 1b. Again, we go and substitute. What means substitution? Your A in this situation is 2, which is the first term, and your common difference in this situation was actually just 5. So your Tn should be very simple to find from where we are. So it's 2 plus 5n minus 5. So I'm going to write it as 5n, that is 5n minus 3. Okay? So that is our general term in this situation. So, perfect. For 2 marks, I think you won't complain. What you may complain about will be this one here. So I'm going to change the number of marks here and say 4 marks. Or maybe 3. Let's say 3 marks. 1 won't work. 3. So what is the question asking? Write down the value of the first term in the sequence that will have a value that is greater than, you see, it has to be greater than 1.7. The value of the first term that is greater than it. So we are saying in this number pattern powers, there are terms that are greater than 1.7. You want to know the first one that is greater than 1.7. So what one may think of doing here is to figure out if 1.7 is even part of the sequence or not. So what you do if you want to figure it out is you substitute 1.7 in place of Tn. So you go and you say 1.7 is equal to 5n minus 3. Then you see the n value there, which is the position. It will be the position of 1.7 if it is in this pattern. So if you get n, which is not an integer, or rather, if you get n, which is not a natural number, then just know that 1.7 is not part of the sequence. If you get n, which is a natural number, it means 1.7 is actually part of the sequence. So when you get the n, you'll be getting the position of this 1.7. So let's go ahead and try. As you can see, we are getting 110 on the side, so getting n is going to be child's play. As we are noticing, we will definitely get a 2 and 2. So actually, it is actually T22, which is equal to 1.7 from what we have gathered. Now, we will not ask the position of 1.7. We will ask for the first term in this sequence, which is greater than 1.7. So if the 22nd term is 1 7, it means the 23rd term must be the one we are looking for here. So how do we get it? We also go and substitute into the general term here. We just put 23. So we're going to say 5 by 23, 5 minus 3. Whatever term we get there is the first term that is greater than 107. Okay? I'm getting 112. And this 112 happens to be greater than 107. So if I ask you, if I say 3 months, let's just keep it track. Okay? So that is what you will be expected to do here. Right? Now, which term of the sequence is equal to 182? So if I put this general formula here, let's just put it first, so you can tell me if you are understanding where 182 should go. So is 182 the position or is the term? Well, I think you said it was the term. We don't want to find a term which is on this position. We are not looking for a term on this position. We want to find the position of 182. So just know the difference. We are calculating n, we have Tn. So in this situation, I'll put my 182 here, and then I'll solve the problem. It is a very easy one to solve, because when you get through to the other side, it will still be 105 over there, and then you simply get your n easily like that. I would like to divide that 7. Right? So in this situation, it is actually T37, which is equal to 182. In the case we wanted us to just summarize that. Okay, this is very simple to use. The formula A plus n minus 1b, I think you're getting the hang of how to use it, so I expect you to be perfect on that one. Okay, but let's move to a different aspect. You know, at times these linear patterns that we're talking about today can be expressed in terms of some variables. They will express it in terms of certain variables, and you will have to figure out a way of seeing what's what. So let me make that one nice and big. Okay, so I hope you can see that the number pattern we've got over there. Well, if you remember very well, I said that if you want the common difference, you can say T2 minus T1. You can say T2 minus T1, or maybe you can say T3 minus T2. It really doesn't matter. You can say T4 minus T3, or you can say T10 minus T9. In actual fact, we ended up saying the common difference is just Tn minus Tn minus 1. That's what we say at the beginning of the lesson. So we are actually going to use this concept right here, and then we are going to calculate these unknowns. The fact that we know that the common difference is constant at all times when we are dealing with a linear pattern is what we are going to use. So look at what I'll do with this one. Firstly, let's make it a space. Okay, it's empty down. Well, what I want us to do now is to substitute into this statement that I just wrote here, which is the common difference. What I know is that if I find the difference between those two terms and also the difference between these ones, then it should be constant, because the first difference is constant. So if I say T2, which in this situation is 2Q plus 2, minus T1, which is just Q, this should be the same as saying T3, which is 5Q, plus 3, and then you subtract T2, because T2 has got more than one term. You see, this whole thing is T2, so I have to put it inside the brackets to make sure that the negative affects everything inside the brackets. Okay, so carry on, let's simplify a bit. 2Q minus Q, I'll just write it as Q plus 2 this side, and then 5Q. Okay, maybe I should just do these unnecessary steps for this first exam. Do you see why I put them in brackets? The negative will affect both 2q and 2. Well, this is still q plus 2. Like I said, I was talking about it. What is 5q minus 2q? And 3 equal to 3q. And 3 minus 2 happens to be 1. So now I am going to take this q to the other side. To the other side, and then reduce it to be 3q minus q. We'll just get 2q here. And when we take that other one to the other side, you should have 2 minus 1, which will just be 1. It does look like our q is f of after all. 1 over 2. So that would be a solution. We have managed to calculate that unknown that was in the arithmetic sequence or in a linear pattern because you just used the fact that the first difference is constant. That is all you are expected to use. It's important to just get a second example for all things. So let's go ahead and use the same principle for here. We have 3 terms, this term, that term, and this term. So I know that if I calculate the difference there, the difference should exactly be the same because we were told it's an arithmetic, remember arithmetic and linear, they use the same number pattern. So we're going to go ahead and substitute. Remember I said you say T2 minus T1, that's how we get this first B, and then that second B we did it by saying T3 minus T2. So if I make my substitutions, T2 is, let's make sure to copy it correctly, minus 2x minus 3. That's T2. Minus T1, look how I put it inside the brackets. Okay, is equal to, let's copy down T3 properly. That's 3x minus 1 minus T2, which is minus 2x minus 3. So here I'm going to just simplify again. We have been going about it a bit slowly, just so everyone can see what's going on here. Okay, so you see that we met our negative sign, affect everything. Now let's take the like terms together. On the left hand side, I'm going to have negative 4x if I just take these two together. And then if I take these two together, I'll get negative 7, right? And then on the right hand side, if I take that one and that one together, I'll get 5x. And then negative 1 plus 3 will definitely give us plus 2. So to finish this off, I'm going to take the negative 4x to the other side, and that will be 5 plus 4, that will be 9x, is negative 9, which will be our x is negative 1. I think you are finding it very easy to notice how to find this unknown variable in the question. So I'm not going to let you know before you do your practice question here. So do this one quickly, answer this one, get your own unknown, and then you will make it out. Well, as you can see, I'm sure you got it right. You still find, you use the common difference there. So you still say T2 minus T1 should be equal to T3 minus T2. That is what we know. So if I make the substitutions, I have 10x in that one is equal to T3, which is 6x plus 1 minus 3x minus 2. If you're subtracting something that has got more than one term, just make sure to put it inside the brackets. I think you don't mind us writing it as negative 7x, taking these two together. And then on the other side, we have 6x and negative 3x here. So I'm going to just write that one as positive 3x. Then we have 1 plus 2. You see it's going to become a plus 2. So we still have a 3. You can simplify it the way you feel like. I'm going to take 7 to the right hand side, so negative 7 will become plus 7. Yes, so 3x plus 7x will be 10x, and then minus 2 minus 3. So that will make it 5. think we are sorted as to what the solution to this should be. So please people, this is what we had for linear patterns. It's a very simple topic, so I know you will be able to do this one in no time at all. So thank you very much for watching this one.